Okay, pre-calculus. So this is our second video. We're looking at finding inverse functions. So in our first video, we looked at how to write the notation. We started to go through the process of how to find the inverse algebraically. So now we're going to do another example here where we're going to find that inverse both algebraically and then confirm it graphically, and how, again, those things connect to one another. So I'm starting here with this function f of x. So I have square root of x minus 3. So remember that the technique in the book that they give us is that we're going to say, instead of f of x, I'm going to say y equals square root of x minus 3, and that I'm going to first switch x and y, and then we're going to solve for y. So by doing it this way, again, we get into not only doing the opposite operations, but also ensuring that we do them in the correct order. So first thing I want to do is, obviously I want to get y by itself, so I'm going to get rid of the square root. So that means we're going to square both sides. So remember, the opposite of the root is the power. So square root, square power. So now that gives me y minus 3. Then we're going to add 3. So it's x squared plus 3. So this is y. So I'm going to write this is our inverse. All right. Now, to write it using the notation that we just finished doing in the previous video, I'm going to say f inverse of x is x squared plus 3. So this is telling me this is the inverse of this original function up here. Now, how can I confirm this? So I'm going to confirm it by graphing. So I'm going to start by making a sketch of my graph here. All right, so pardon that it's a little shaky. I didn't take out the ruler. So I'm just doing this for time for a video. And I'm going to start by plotting this first graph. So this is at 3, 0. Because I know at 3, the answer would be 3 minus 3 is 0, square root of 0 is 0. So then if I do 4, the answer would be 1. So it would be 4 minus 3 is 1, square root of 1 is 1. So, and I'm going to do one more point, because this is how I'm going to confirm graphically that this is correct. So if I do 7, so 7 minus 3 would be 4. Square root of 4 is 2. So when we make our graphs, I want to make sure I label the graph and I put at least 3 points. So I got my 3 points here. Now, if this is in fact the inverse, remember graphically, how do we find the inverse? We take points from our original function, and if we switch the x and the y, that's going to give us the points on the inverse. So at 0, 3, and I'm going to do the inverse in blue. So at 0, 3, at 1, 4, and then at 7, 2. Okay. Now, if I were to actually graph this, there would be this other side to it, this other side of the parabola. But then it wouldn't be the true inverse, because you see here we only have this piece here, so it should only be just that part. So that means there's a restriction that we got to put here. So this is a special case, and the restriction is that x has to be greater than or equal to 0. So how do I know this? Why does it have to be greater than or equal to 0? So graphically, I can see that. But when we do this step, when I switch the x and the y right here, this is how you know x has to be greater than 0. Because if when I write this, look at the square root. There's no minus here. It's only plus. So that tells me x has to be a non-negative number. That's where this comes in. If this original problem started like this with a negative, this would have been negative, that would have been negative, and then when I get down here, I would have said, oh, it's less than or equal to 0, because then this graph would have been down here, and then I would have graphed that part. Okay? But for the example that we did, that's not the case. So I'm going to put it back the way that it was. It's greater than or equal to 0. These are not negative. These started out as positives. Because remember, these are functions. Functions are only supposed to give us one answer. So that's why when I took the square root, it's not like, oh, 4 minus 3 is 1. Square root of 1 is plus or minus 1. Because if I would have done that, and I would have graphed all of it, then you see we don't have a function. We don't pass that vertical line test. So this, we solved for the inverse function. I did it both algebraically, and then I confirmed my answer by looking at it graphically. All right, let's do one more example. I'm going to do an easier one this time, nothing that involves us restricting the domain. So let's go ahead and we'll look at the following. So I'm going to say this time we're going to go and do x plus 1 divided by 3. All right, so we want to first find the inverse function. So I'm going to do it algebraically, and then we're going to confirm graphically. So first write y, and then we're going to switch x and y. And then we're going to solve for y. So we'll multiply by 3. And then we'll subtract by 1. And here is our inverse. So I'm going to write the inverse over here in blue. So inverse of f is 3x minus 1. Okay? So let's confirm graphically. So I'm going to plot my original function. So I'm going to do that in red. Okay, so I'm going to pick some numbers. So I'm going to pick some nice numbers here. So 2. So when x is 2, 2 plus 1 is 3. 3 over 3 is 1. So 2, if I plug in 2, the answer is 1. Then if I plug in 5, the answer would be 2. And I'm going to pick one more point. All right. So keep going down this route. So then at 8, the answer would be 3. So we see that that's the equation of a line. So yeah, I'm going to draw this straight line. All right. Now, how do we graph the inverse? So I'm going to confirm this. So the way I'm going to confirm it is by, okay, to graph the inverse, what do? We switch the x and y coordinates around. So my inverse should be at 1, 2. 2, 5. So let me put, 2, 5 over here. And 3, 8. So 3, 8, so somewhere up here. And we see that that would be the equation of a line as well. So I'm just making the sketch of the graph. Okay, so how can I confirm? These points should be points on here. So here's how I can check even more. Okay, according to this, if I plug in 1, the answer is 2. Well, let's check. If we plug in 1, so that'll be 3 times 1 minus 1, which is 2. So that checks. What about 2, 5? Let's plug in 2. So 3 times 2 is 6, minus 1 is 5. Yep, that checks out. And I can do it with the third point, and we will get, yeah, that also checks out. So 3 times 3 minus 1 is 8. So hopefully you found this video helpful. Again, if so, hit the like, hit the like button at the bottom of the video. That lets me know that you found this useful, helpful, entertaining. Hit the subscribe button as well, so that way you get alerts to new videos that come out. So in the next video, we're going to now look at, so we're able to find the inverse function, but what if I wanted to prove that two functions are inverses to one another? How do I go about doing that process? What's the work involved? So that's what's coming in the next video, and I'll see you in the next one.